Hello, this is Sadbil. The topic of our discussion in this video is first order linear differential equation. In the classification of differential equation, the first order linear differential equation is a differential equation which is an ordinary differential equation of order 1 or linear, or they have also linear degree. The standard form or the general form of the linear differential equation, which are of degree 1 and order 1, is this. As you can see here, it is the first order of degree 1, and also the variable y, which is a dependent variable, is of degree 1. That is, it is also linear. So if a differential equation is of order 1 and y prime, which is a dy by dx, they are both of degree 1, then that differential equation is first order linear differential equation. And this is the standard form of the first order linear differential equation, where p and q, they are both continued function of x. Here is one example. In this example, this is a first order linear differential equation. Our px function is minus k, because whatever the coefficient of y is a px function, and qx function, which is on the right hand side, which is a 0 function. One more example. As you can see, this is also a first order linear differential equation, but it is not written in the standard form. So to write that in the standard form, the very first step is you clear off whatever is in front of dy by dx. So if I write dy by dx and divide x square plus 3y square divided by x, then I can further write x square divided by x plus 3y divided by x. And in the second step, I will move the term y on the left hand side, dy by dx. It will be 3 divided by x, y is equal to x squared divided by x is x. So now this is my standard form. And in that standard form, my function p of x is a minus 3 divided by x, and my function q of x is just x. Let me give you one more example. This is also a first order linear differential equation. As you can see that the dy by dx is of degree 1, and the variable y, which is dependent, its degree is also 1. And I can write this differential equation in a standard form. First, I will clear my dy by dx term. So that will give you x square minus y, divide both sides by x. And then this can be written as x square over x square minus y over x square. And this can be written as 1 minus 1 over x square times y. And I will move in the last step the term which involve y on the other side. So dy by dx plus 1 over x square times y is equal to 1. So here you can see this is my term px, and this is my term qx. So this is in a standard form where px is a 1 over x square and the term qx is just 1. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. How to solve first order linear differential equation? So there are three-step process. This method is involving the 3-step. In step number 1, we will identify our equation, whether it is a first order linear differential equation or it is not. If it is not a first order linear differential equation, we will not proceed to the step number 2 and 3. And in step number 2, we will calculate the integrating factor. If our differential equation is a first order linear differential equation, the step number 2 is to calculate this function I of x, which is a e to the power integration of px dx. And once we calculate that function, in step number 3, we can write the general solution as y is equal to 1 over integrating factor. Integrating factor is multiplied to the function qx, and then you add one constant there. So that will be your general solution of your first order linear differential equation. Notice one thing, in order to have a solution on this function px and the function qx must be integrable. If you cannot compute that integration, you will not be able to calculate the solution of that first order differential equation. Let's take one example and solve this first order linear differential equation using the previous method. So here, first thing we have to do is, in step number 1, we have to identify whether it is a first order differential equation or not. As you can see, it is, because it's also written in a standard form. So the first I will write what is my function px, which is a minus k, and my function qx, which is on the right hand side, which is a function 0. And in step number 2, we are going to calculate the integrating factor, which is called ix, which will be in e to the power integration of px, which is a minus k dx. And if I do this integration, this is going to be ex, because e to the power minus kx, because k is a constant. Now we will move to the step number 2. In step number 3, in step number 3, we will write down the general solution as 1 over integrating factor, which is e to the power minus kx. Now the integration of the function e to the power minus kx, there will be a parentheses here, time qx, which is a 0 function, dx plus a constant of the integration c. So this is a 0 time e to the power minus kx, which will become 0. Therefore, this is a 0, so it's going to get e to the power kx. I can move e to the power kx in the numerator and switch the sign. And this is going to become 0 plus c. So the general solution is a c time e to the power kx. You can also verify your solution by plugging back into the equation if you want to do that. So in order to verify your solution, so all you need to do is you have y is equal to c e raised to power kx, and then you have dy by dx is equal to c k e to the power kx. And if I plug back into the equation like here, then I got dy by dx is c k e to the power kx minus k time y, which is a c e to the power kx, is equal to 0. So which is, you can see 0 is equal to 0. So indeed, this is your general solution of the this first order partial differential equation. Let me take one more example. In this case, as you can see, this is a first order linear differential equation. So first step is to identify the differential equation and turn that differential equation into standard form. So the first order, because the dy by dx is of degree 1, y is also of degree 1. So this is the first order linear differential equation. First, I will divide by x square on both sides. So I get dy by dx is equal to x plus 3 over x times y. And in the next step, I will write dy by dx and minus 3 divided by x, y is equal to x. This is the standard form of the equation. So it means this function is a px and this function is qx. It is very important, before you solve any differential equation, it's very important to first identify what type of that differential equation is. Now we can move to the step number 2 and calculate the integrating factor. So calculating the integrating factor, or other word, ex function. So we have to e to the power integrate this px, which is a minus 3 divided by x dx. So the integration of this function, which is a minus 3 divided by x, is minus 3 natural log of x. Now I will use few property of the natural log and exponential function to simplify this more. So this is going to be e to the power natural log of x to the power minus 3, because you can move this power on the top of x by using natural log property. This and this they are inverse to each other, they will cancel out, so our integrating factor is a minus x to the power minus 3, which in fact is equal to x to the power 1 over x to the power 3. So this is our integrating factor. So once we have the integrating factor, we can write down the general solution. I will do in step number 3. My general solution of the differential equation is 1 over integrating factor, which is a 1 over x cube, and then parentheses integration of the function qx, which is x, time the integrating factor, which is the 1 over x to the power 3 dx plus c, and this is equal to 1 over x cube is just x cube, and this function cancel out, become 1 over x square dx plus c. Now simply we have to integrate this function, which is a 1 over x square. So the integration of this function is going to be x to the power minus 1 and then minus 1 here and plus c. So therefore, if I get some space here, therefore if I simplify this one, this is going to be x square minus x square plus cx cube. So this is my solution. Therefore y is equal to minus x square plus cx cube. So here I have one more example problem. Our differential equation is 3x dy by dx minus y is equal to natural log of x plus 1 when x is a positive, and we would like to find a special solution which satisfy this condition. So the procedure is same. It's a 3-step process. In step number 1, we will calculate the standard form of the differential equation by first free dy by dx. We will divide by 3x on both sides. So it's going to get 1 over 3x. And then you get y. And then you have natural log of x plus 1 divided by 3x. So this has become our standard form. This is our function p and this is our function q. So we will proceed to the step number 2. In step number 2, we are calculating integrating factor, which is ix, and it is e to the power integration of minus 1 over 3x dx, which is our function px. So it's going to be e to the power minus 1 over 3 natural log of x, because the integration of 1 over x is the natural log of x. So using the property of natural log, I can put that one on the top of my function, become x to the power negative 1/3. So this will cancel out and I have 1 over x to the power 1/3 as my integrating factor. So this is an important function for us to write down the solution of our differential equation. Step number 3, our general solution is a y is equal to integrating factor 1 over integrating factor, which is a 1 over x to the power 1/3. And then we use the parentheses, integrate the integrating factor 1 over x to the power 1/3 time the function qx, which is a natural log of x plus 1 divided by 3 x and dx plus c. So now we will simplify this function and compute this integration. So after calculating this integrations, our function y is equal to minus natural log of x minus 4 plus c times x to the power 1/3 is our general solution. So in step number 4, we will calculate this constant c from this condition which is given. So we have given that at 1, the our dependent variable is equal to -2. So I plug x is equal to 1 and set y is equal to 2. So this is the natural log of 1 minus 4 plus c x to the power 1/3. It means 1 to the power 1/3 is just 1. Natural log of this is 0. Therefore, c is equal to 2 plus 4, which is 6. So our special solution in this case is y is equal to minus natural log of x minus 4 plus 6x to the power 1/3. So this is our special solution for this differential equation. Here I have one more quiz problem for you to practice. Please pause the video for 1-2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.